Hello everyone, I am Anjali Shukla. Welcome to our channel PG Cloud Security. This is a series on OWASP EKS code, and today we will discuss Kubernetes architecture. Let's get started. You can find the documentation at ekscode.pgcloudsecurity.com, and today I am discussing 5.1.1 Kubernetes architecture. Kubernetes mainly has two components, control plane and worker node. Control plane has API server, etcd, scheduler, kube controller manager, cloud controller manager. Whereas worker node has kubelet, kube proxy, and container runtime. This is a diagram where we can find all the segregation. Like in control plane, we have these 5 components, and in each node we have kubelet, kube proxy, and container runtime. Let's understand these components in detail. First, we have API server in control plane, which takes care of all the administrative tasks in our cluster, like authentication, authorization, resource management, and it handles all the API requests from users and cluster components. Next, we have etcd, which is key value database and should be highly available because it stores all the metadata information of the resources or objects running in our cluster. That is pods, services, deployment, RBAC, everything. Next, we have kube scheduler, which is responsible for scheduling pods on node with respect to the available resources. So whenever new pod creation request comes and the pod wants 1 core of CPU and 500 MB of memory, then it is the responsibility of scheduler to check on which node these resources are available and schedules the pod. Next, we have a kube controller manager, which takes care that your cluster is present in desired state and it continuously watch our cluster for all the changes happening in our cluster. Like if the pod goes down and it is mentioned that 4 replicas should be running, it is the responsibility of controller manager to spin up another replica of that pod to make sure all the time 4 replicas are running. It has built-in controllers like replica set controller, deployment controller. And next we have a cloud controller manager. This is important because it presents only when our Kubernetes is managed by a cloud provider, because this is a key component that makes all the communication between your cluster and cloud services. Let's say you want to create an elastic load balancer, which is another AWS service. That is a responsibility of cloud controller manager, which will send request and make sure that the load balancer is created. Next, we have worker node, and it has kubelet, kube proxy, and container runtime. Kubelet is responsible for communication from the worker side where workloads are running. And also it interacts with the container runtime to manage containers. Kube proxy is responsible for network related tasks, making sure that pods have all the necessary required communication. And next we have a container runtime, which actually spin up a container when there is a pod creation request. You must have heard about Docker, Containerd. So those are responsible for spinning up a container or a pod. Let's understand the architecture. I would like to go back to this diagram. Whenever there is a user request, let's say a pod creation, user sends it using kubectl, and that request is sent to kube API server, and it stores that information in etcd because it is a new pod or any change request. It stores everything in etcd. Then it connects with the scheduler to check on which node those resources are present. So scheduler selects a suitable worker node and scheduler pod. Next, controller manager takes care that pod is present in its running states. Once scheduler identifies a node, let's say it is scheduling a pod on node 2, then kubelet receives that request from the API server, and further it connects with the kube proxy and container runtime to spin container. Once the container is up and running, CRI connects back with the kubelet, updating the status that it is running, and then kubelet update this status to API server, and API server stores this updated state in etcd database. That's how the entire process takes place. So that was it in this Kubernetes architecture. In further videos, I'll discuss AWS EKS terminologies. So stay tuned and thanks for watching.